All right, how's everyone doing today? Cool. So, she already covered our first question. We were going to ask who knows RxJS, and no, it's cool. Beat us to the punch. All right, so I'm Gosselin, and we're both from Wrangle.
I'm Daniel.
And today we're going to be talking about RxJS, the good parts. So, what is RxJS? The first time I saw RxJS, this is what went through my brain. I was like, okay, so I got maps, I got filters, there seems to be some kind of way to do asynchronous programming. Not really sure. It looks like a promise or an array. This is kind of what I visualize it like now. I kind of see it almost as like a funnel. So I take like a little ball. I kind of think of them as like those balls they use for, what is it, bingo? Yeah, bingo. And I take the ball and I throw it down a funnel. And as it goes down the funnel, multiple things are applied to it. Let's say a map, a filter, a reduce. And every single time I throw a ball down this funnel, it gets the operators applied to it. And then at the very, very end, something gets spit out. Or, every single time a ball goes through the funnel. Depends on the operators.
Right, so how does that relate to Angular at all? It's everywhere. So if you guys have had experience with Angular 2, you know that HTTP modules, routers, outputs, forms, they all have observables sneaked in. So it's really important for us to have an idea of what are the common operators, how we can handle errors with RxJS, how we can type the observables so we can get some compile time errors, which are super handy. And we also had an example of RxJS versus regular arrays. We're going to get deep into it later.
So firstly, we're going to talk about common operators. So this part of the talk I actually crowdsourced from my company. So we're a team of about 165, give or take. So I went over to maybe, I think, 30 or 40 people, and I took a survey. What are your favorite operators? Why? The lowest ones didn't make the cut. And we're about to show you what came to the top. So creating observables. Obviously, these had to make the cut, because otherwise we wouldn't have observables. So observable of. It takes it as functional parameter arguments. So A, comma, B, comma, C. So if you wanted to pass to an observable, say 1, 2, 3, it would be 1, comma, 2, comma, 3. Pretty simple. Observable from gives you a little bit more flexibility. You can pass any kind of iterable, a promise, and it'll convert it into an observable for you. And then we have array-like operators, which is coming back to the beginning of the talk where I said it reminds me of an array. I'm sure, here, who knows what a filter is? Okay. So it is exactly the same thing as the array filter, but in this case, it applies to a single number going through at a single time. So filter, if it passes, it continues on. Map, because most of the people know filter, I'll assume you guys know map. It makes you allow to do an operation, a modification onto the number as it's going through the pipeline. Reduce, same thing as the array reduce. So you can actually combine all your numbers into a single number or do whatever you want. It basically allows you to iterate all over the numbers and return a single output. And then take, really, really good for HTTP, because HTTP generally only gives one response. So if you go take one, it'll clean up the observable for you, and you don't have to dispose of it. And then useful for browser events. How about debounce? Does anyone know debounce? Okay, oh, less people, awesome. So the way I think of debounce is I'm mashing my hands on a keyboard like this, keyboard cat, let's just go like this. And then I have to wait X amount of time before I stop doing this in order for the next event to actually fire. So if I keep doing this, only one event will fire. Whereas throttle, on the other hand, is similar but different. So if I keep doing this, it'll actually fire every X amount of milliseconds. So if I'm doing this, it'll fire once, let's wait a second, fire again. So I don't actually have to stop. That's throttle. And then we have combining observables. So switch map, I think it used to be called flat map, pretty sure. And switch map allows you to return an observable as you're going through. So, yeah, okay. Sorry. So if I'm making an API request, because of like a key event, and that one doesn't finish, if I hit another key, then the previous one will actually get canceled. Whereas merge map, on the other hand, every single, like, say, keystroke, if it's hooked up to an HTTP request, it'll fire every single time. So they're very particular, like, they're very specific differences, but you have to be really careful with it. Otherwise, you can end up with, like, a lot of overhead. .zip, I use it in terms of combining all my HTTP requests. So if I have, like, 5, I'll throw them in a .zip, and then the .zip will combine all the requests and give you all of them at once. Combine latest. So let's say if you have 5 different observables all tied to a different keystroke or something like that, whenever one of those keystrokes gets hit, it'll give you all the latest data from all your observables. And then useful utils. .array, just like it sounds, it'll combine all your data from the observable into an array. So let's say if you pass an array into your observable, 1, 2, 3, and then you do a .toArray, your subscribe will be an array of 1, 2, 3. Otherwise, it would be 1, and then it'll fire again, 2, fire again, 3. And then .share. So .share is a very interesting one, because if you have an observable hooked up to an HTTP request, and you only want that to fire once, it's actually going to fire every single time, unless you use .share. So that's what that used to use for. And in case of errors, if your observable ever fails, you can use .retry. It's good for, again, HTTP requests.
All right, so wait, what happens if an error happens? That's usually my face when something happens. So the errors, they go in a specific channel called on-error channel. We're going to get deep into this, but basically you can attach a callback that will be called whenever an error happens, and you are provided the error as an argument of your function. The errors, another important thing is that the errors halt the sequence. So if an error happens, the observable will stop. And this is very important to know. And there are 2 levels of errors. There are class level errors and instance level errors. We're talking about class level errors. Usually, you want to deal with multiple observables at the same time. And one of the use cases is swallowing errors. Let's get an example of that. So this sample, what it does is basically, it's going to try to perform the first request. If an error happens, it will try the second. And if an error happens, it will try the last one. So it doesn't really matter what's the error that is being thrown. It's just that it will keep trying to something successful, or all the options are gone. So in this case, you want to make sure that your last option is something that you're sure that it's not going to fail. So we can also ignore errors and continue with the operations. Let's say you have a bunch of things that you want to execute, and all these things, regardless of the output of each particular observable, you just want them to all be executed in a series. In this case, what you can do is you can use another operator. There are a bunch of other operators that perform different things in RxJS. If you go to the documentation, you're going to see that there's several options. These are just examples. In this case, the on-error resume next callback will try to execute all the functions, and data will be function 1, function 2, 3, as long as all these observables are successful. And then we go to instance level errors. This is what we usually expect from an error handler. So let's say that you want to deal with the error, map it to a different payload, something that your application is used to. So what you can do is you can use the catch operator, which basically is like a try-catch in JavaScript. You're going to receive the error when something happens, and your callback will be called with the error. And what your callback should return is another observable. And that observable is what your subscription is going to receive. So an example is we're doing an AJAX call here to get that resource. Let's say that service isn't available or something's happening. This callback function will receive the error, and all I have to do is just return an observable out of it. It's pretty simple. And the same way you can use catch, they also have a finally operator. So I don't know if you guys know about RxJS, but you have sort of 3 callbacks. You have when you subscribe, when an error, and when the observable is completed. Finally it's only called when the observable is completed. The only difference between the complete callback and the finally is because finally will be called regardless, even if an error happens. So the classic use case for this is when you clean up resources. So let's say I have a socket open, and I'm streaming data, reading from the database. Imagine that get data, it's an observable that keeps emitting values until all the data was being read. If an error happens, it will stop the observable, and we'll call finally right after. So I can close my socket and make sure I freed all the resources after. And we talked about TypeScript and how can we leverage TypeScript observables so we can get compiler error times, which are super handy. Why? What's the advantage of having types? It helps you get compiler errors, as I mentioned. It forces you to return a non-object. It will fail if you're not providing the type you want. And also, whoever is using this, any other dev, if you have functions that return a specific observable and this observable is typed, it's easy to understand what you're going to get out of it. So it also saves a bit of development time. How can we use these generic arguments? So RxJS has generic parameters for all the operators and for the observable itself. The observable has a generic argument, which is what you're going to receive when you subscribe to that observable. And you also have generic parameters when you're performing some operations. Let's say you're performing a map operation or a merge operation. You also have to provide the generic arguments for those operations. Yep. And this is an example. So let's say that I want to create an observable that returns a cat. And I'm trying here to provide an object which does not match the interface. And you indeed get an error. This is the error you're probably going to see on your TypeScript is object's not assignable to that type because we're not providing the method per. Okay, so let's get a little bit more complicated in this. We know that observables, like Chris mentioned, have a bunch of operators. We can merge observables, we can map, combine. So how that works with the generic arguments and the types. Let's get an example. So let's say that we want to map our observable from a specific type X to a type Y. In this case, map has two generic parameters. The first one is the observable, the type of the observable you're getting in. So let's say we are receiving a cat, as we've seen previously. And the type that you're going to return after. I'm basically mapping from the first type to the second. And the way that I can do this is providing these two arguments in my operator. So let's say that I want to get this resource. I know that the type I'm going to receive is a cat. And all I want to do is map it to a dog. So TypeScript will fail if what I'm returning is not a dog, which is also pretty cool.
Just had to turn my mic back on. All right. So this one's an actual kind of a weird one. I was having a talk over dinner last night, and there's still kind of a little particular about how this actually works. But I'm pretty positive. I'm going to go into the why after. So anyways, I want to thank Michael Bennett for this part of my talk. He came up with this idea, and at first I didn't believe him. And then we did some benchmark testing, and lo and behold, it's true. So performance in RxJS. JS array operators versus RxJS operators. I'll just keep going. So this is the test. We take 1 million elements in an array, and we're going to do a few operations over them. We're going to do it in the array with array operators, and we're going to do it with observables, with observable operators. So as I talked before, observables work like a funnel, whereas arrays, it's more iterative. Okay, let's keep going. So here's the array setup. I take 1 million elements that are randomly generated. I'm going to find the even ones. I'm going to multiply by 5. And then I'm going to reduce them and just add them together. Very simple. Not that complicated. And I do the exact same thing with the array. So I use that from operator that we were talking about. Take the array, turn it into an observable. And then I'm going to do a filter, a map, and then a reduce. And dot subscribe. So remember that observables are inherently synchronous, so that's how the whole scoping thing works. So that's why it's going to return the value. And then the results. So I would think that the array operator would be quicker. I thought RxJS would have a little bit more overhead, but it's not. So the arrays actually took 0.14 seconds, whereas RxJS took 0.8 seconds. It's almost like half as less. So, scratching my head, I was like wondering why. Why is this so? So it's actually because of iterating over the whole array. So RxJS works like a funnel, whereas arrays are going to have to map through that 1 million elements 3 times. Well, I mean, 500,000 because every even number, and then 500,000, and then 500,000. But RxJS, on the other hand, you take that number and you throw it down the funnel, and it gets all 3 operators applied to it right away. Whereas arrays have to actually go through those 500,000 elements 3 times. So that's actually where this comes from. The arrays actually have overhead, whereas RxJS doesn't have the same overhead. It iterates over all the numbers once. And that's actually how you can use RxJS to make your code more performant if you have really large data sets. So I just want to say thanks to everyone for coming out. This was a much bigger turnout. I was expecting a crowd of 30. I was over there, I was like, oh, wow, this is a lot bigger, times 10, at least, maybe. So Daniel, do you have anything to say?
Yeah, thank you all.
Thanks for everyone coming.
Who has the question? Raise your hand if you have any RxJS questions.
We could also treat it like an AMA if you want.
So how does the reduce thing works at the end of the funnel?
Sorry, okay, guys, we can't hear. Hold on. Go ahead, what?
So the previous example that you showed, where arrays are iterative and observers are acting like funnel. So at the end of the funnel, where you have a reduce, how do you reduce that to a single element, where if each individual elements are coming one by one?
You want to come up?
I think I get it. It's like how the reduce will work because the elements are coming one by one. Yeah, so the reduce will fire with a default value, start value, and then after the second iteration, it starts getting the previous value. It's basically like the default array. Yeah. Okay, so he asked, you want to take this? So he asked how the reduce will work at the very end because we're piping a bunch of different operators. So we have a map, a filter, and a reduce. But with RxJS, the idea is that you get one element at a time, and the reduce needs 2 elements because it's always the previous and the next, which you're combining. So how that works. I don't know exactly how internally RxJS will handle that, but your reducer will receive both values, the current and the previous, at the start. So you probably start with a null previous value, and the current is the first element you're getting in. And after the second iteration, your next value will be the previous, and you start getting.
Actually, I think maybe you're talking about because how is it going to reduce? Because every single number is going to come through the subscribe. Is that what you're saying?
Yeah.
Yeah, because it takes all the numbers and it does it on complete. So reduce actually won't continue on until all the numbers come through it. So it's more of it's like normally you take a number and you put it through the funnel and it comes out the other end and you'll get multiples. But reduce actually combines all of them into one. Does that make sense? There's a few operators like that, like to array, and instead of firing on every single number, it waits until the previous is all complete, and then it actually bunches them together and does that for you. I can't hear you, but.
I cannot.
You can.
I can.
You can.
And the map has to return an array, or does it can return?
No, map goes through. So there's only a few special arguments, special things that'll actually do kind of an on-complete thing. So an array returns the entire array, when you do a dot filter on an array. So there's a few operators like that. ToArray is one of them. Reduce is one of them. If you want the non-array-like version, if you want the non-array-like version of reduce, then you want to use a scan. I think it's scan, right?
The question was, similar to what the
Array?
map function in arrays.
Yeah, it's the exact
Yeah,
same thing, except for
way
it's
that
not
it-
going to return an entirely new array, or because like it's only returning a new element. So RxJS it's like operations on one element, and then it keeps feeding those elements at the very end. So it's more like that. It'll map over it still and like allow you to make a change, but it'll do one element at a time.
In the case of reduce, I don't know if you have the default argument, because the regular reduce function from MDM, you have the last argument, just the start value you want to give it. I'm not sure if RxJS has that, but it basically works exactly the same way. You get a null value for the first iteration, and you get both values thereafter. Make sense?
Yeah, thanks.